Okay, so that's centered. So now we're coming back to the main geometric idea. And I gave you a little bit of time to think about it, and you were not, you don't see, nothing's coming to mind, right?
No, not really.
Okay, so let's go to the idea that you had that I probably should have pursued a little bit more than I did. So what was the idea that you had when we were talking about this?
You could somehow create congruent triangles if you drew a new line like that.
Okay. So we draw this line here, and we're hoping. Let me see if I can get that a little bit bigger. Mm-hmm. Yeah. Okay. So we draw that line there, and we're hoping, give you the pencil, that we can create congruent triangles.
Okay. So let's see. We know that we don't know that this is. We know everything else. We don't know that this side is equal.
Right. We don't. That's exactly right. We're trying to understand if this side is equal to this side. They are marked as equal in the picture, but we don't know that is true.
So we know that both triangles share this side and this side.
Okay.
And they also share an angle because we have a right angle here, which means this is also a right angle, and then this was a right angle in the triangle.
All right.
So we have SSA, congruency.
Mm-hmm.
And so that means that this side will be the same as this side in the triangle.
Yeah, and even with that, without the side-side angle congruency, we now have right triangles that have a leg and a hypotenuse the same.
Yeah. So by the Pythagorean theorem,
So by the Pythagorean theorem, that side length has to be the same. And so that's great. So your idea actually did prove it. So it was my mistake to not explore that a little bit further because I was too focused on the other thing, which actually you have now just proved. So the other idea is that if you have a point outside of a circle.
Yep.
Actually, instead of trying to do this zoomed in on the piece of paper, we have a point outside of the circle. The two tangents to the circle from that point, which aren't, this is the radius, this is the radius. This is the distance. The distance from the point to the circle, either direction you go, is what?
I guess they're the same.
They're the same. So the distance from a point to a circle on the tangent lines is the same no matter which tangent line you go on.
Okay.
And that's how you prove it. You draw that line in, and then you show that those are two congruent right triangles. And so when we come back here, you see what we have is a point outside of the circle, and you see, why are those the two tangent lines?
Because, you drew the circle from those two. You drew the part of the circle from those 2 points.
Okay, but there's also an important property that tangent lines have.
They only touch the circle once.
They touch the circle at one point, but in a very particular way, because this line also touches the circle just at a particular point.
One and only one point. If you extended the circle and the line, that would pass.
That would pass through again. Okay, yeah, one and only one point. And there's something that happens at that point, at the tangent line.
The tangent line is parallel to the circle, locally at that.
Okay, yeah, that's actually an important property from calculus. And so what does that mean about the circle and the tangent line at that point?
Well, they're parallel and they meet at one point.
Yeah, what's an important property, or what's a name some things that are associated with circles?
Like arcs, chords.
Keep going. a circle, and the circle has other things associated with it.
Radius,
Yeah, the
diameter,
radius, diameter.
circumference.
Okay, so if I talk about the radius of the circle here, where's the radius of the circle? How does it intersect with the tangent line?
The radius and the tangent line meet, and they form a right angle.
Yeah, they're perpendicular. So that's one of the critical points. A tangent line is perpendicular to the radius.
Okay.
So that's the critical point. So there we go. So there we have that idea. That idea that the distance from the point to the circle on the tangent line is the same sort of solves it immediately for us. But as you showed, we can actually do the work and prove it, which is good. And we can also just do it computationally, which is also good. All right, so good work this morning.